Good afternoon, everyone from rural Newfoundland. Just checking in today. Thanks for all the love this week. My stuff went viral there for a bit. What I'm going to jump into now, I'm working on a prod training project for my Ukrainian friends on exploit development, and we're starting off at the very basics because a lot of these hackers don't have any experience in assembly or exploit development. So the first thing you need to do is understand the stack and how the stack memory works, and then how to find things on the stack. So what I'm going to do, let's take this image down. I'm going to jump over to my Ubuntu where I live. And what we're going to do, we're going to dissect this my stack program. Basically, it's just a small int main argument count, argument vector. And it has an integer A, which will put 15 on the stack, an integer B, which will put 23 on the stack, and a character pointer, my string, that says hello. Return 0, we will look at this. The exit return to libc is right next to the base pointer when we get into it. So I will show you that in just a minute. We won't jump right into that. I want to show you this little diagram. So I'll show you how the stack gets created when we get into the program. But basically what happens is the stack pointer and the base pointer get moved together. The base pointer gets subtracted from the stack pointer and creates the stack within. So it'll be like a hex, like x020, and it'll be 16 bytes, something along that lines. Once it does, the EBP is right next to the return address of libc main. And we will be doing what is really important to know, that because that's what you overwrite when you start doing buffer overflows. But for this lesson here is just to show you stack creation and how things get put onto the stack, just as I build people up to a buffer overflow. So right next to the return address libc main, you also have the argument count, and then you have the argument vector right next to it. So this may seem confusing. What I'll do, I'll jump right into the GDB and I'll show you how it's done. So that's on my desktop, and then should be day 1, ls-l. Okay, so I have a bunch of stuff put together here. This is going to be the full training package. I'm just going to show you guys a little bit on stack creation today. So GDB is going to open up. That's where I live. And my stack. Okay, so the first thing we have to do is disassemble the main. And what I'll show you right now is the preamble to making the stack is all right here. So basically what happens first is it pushes the base pointer, EBP, onto the stack. It then moves the stack pointer to where the base pointer is at the same memory. They're at the exact same size. Size is 0. They're on the exact same place of memory. Then from there, it subtracts 0x10 in hex from the ESP and creates the stack. It fills the stack up with just garble, values that don't mean anything at the beginning, and then it will start putting in the variables that we've listed in the program right here. So clear as mud, we'll jump into it and I'll show you. It makes a lot more sense once we get going. So if I can spell it right, display, I want to, actually what we will do, we can see it's subtracting 0x10 from the stack. So if I go print 0x10, it is 16 bytes. So that's how big our stack's going to be. So what I will do, so then each variable within the stack, or each section within the stack, is broken down in what's called a word. A word is 4 bytes in the stack. So easy enough. I'm not a math whiz, so that would be 4 words. Then you need, that's just the stack itself. Then you need the base pointer, the return address, and the 2 argument functions as well. So that's another 1, 2, 3, 4. So we're looking at 8. So what I will do, I want to display, I'm going to say 12 words a hex from ESP. Next, I'm going to display 2 instances of EIP, which is the index pointer, and that points to what the program is going to execute next, and it lets us see what's happening. So what I will do, I'm going to set a breakpoint right at this part of the memory where it moves the stack pointer and the base pointer together. And we'll walk through just how the stack is created. Okay, so I think we're ready. We can run our program. Okay, so this up right here is the two instances of EIP, and here we have our stack right here from the ESP. So the ESP and the ESP is right here. Next is going to move the base pointer into the same as the ESP. So what I'll do, I'll print ESP, and as you can see, it's at 0E8, which is this area right here. So let's print, where's the EBP? The EBP is not going to be on the stack, and as you can see, it's 0, 0. Why? Because the EBP hasn't been pushed yet. That's the next instruction that's happening right here. That you can see this arrow pointing towards it. So I'm going to hit NI for next instruction. Now let's have a look at print EBP. And as you can see, EBP is at E8 now, the exact same place as we can check our stack pointer. So they're both sitting at the same spot. So now the next thing that happens within stack creation is it's going to subtract from the ESP. And it says here, it's going to subtract 0x10. After a while doing this, you will start learning hex just through osmosis. But just for demonstration purposes, we'll print and we can see it's going to be 16. So it's going to subtract 16 from the stack pointer, and that's where the base pointer is going to be. Let's hit next. And what I can do, I can print ESP minus EBP at this point. And as you can see, it's 16 bytes apart. So let's print ESP. And as you can see, ESP is at 0D8, which is this one right here. And let's print, print EBP. And as you can see, that's now at E8. So that's this one right here. So our stack is this right here. Now this is garble. These three right here are just null values, just whatever it throws in just to make the stack create. Now to the right of the return address, as I showed you in my graphic, you have the return address, the return 0 exit address. You have the argument count, which is only one. The argument count, the first argument count is just the name of the program itself. If we had an input, it'd be 2. And then the argument vector is over right here. So we would be able to look at the arguments there, but not in this program here. That's for another class. Okay, so now we're going to move, now that the stack's created, we've got this full stack created. Now it's going to start putting the variables onto the stack. So the next move we have is 0xf. So let's go back to our program and open up my stack. And as you can see in here, integer A is 15. So that's going to be the next moving on to the stack. So if we do print 0xf, we can see that's 15. Everything is in hex when it gets moved onto the memory. So hex is really really important to learn for this stuff. And then 0xc, but you can always just do what I'm doing right here if you're unsure. So it's going to move it 12, that value 15, 12 from the EBP. Okay, so we know our EBP is right here. It starts at 0, so 0, 1, 2, 3. This address here. 4, 5, 6, 7 in this address here. 8, 9, 10, 11 in this address here. And 12 will be right here. So that's this program to move along 15 into this address right here. As you can see, it's just garbled junk. That doesn't mean anything right now. Let's hit next NI for next instruction. And as you can see, the garble that was here is now replaced with that 0xf, which is hex for 15. So that's in this section here. Cool, right? So let's take a look, go back and take a look at our my stack again. The next integer is integer B, and it's going to move 23 onto the stack. Okay, so let's go have a look at that in the stack. And as you can see here in the index pointer, the next move, L, is going to move 0x17, 8 bytes from EBP. Okay, so too easy. We know where EBP is. We figured that out. So what we can do now, let's just double check, because this is an introduction. You will get super used to this and you won't have to go through this method, but I just want you guys to learn. So that's our 23 we seen, and it's moving at 0x8. So we can print 0x8. What is it? 8, of course. So here we are at our base point. We got 3, 4, 5, 6, 7, and then 8. So this garble stuff here that doesn't mean anything, we'll just put it in your stack creation. We'll get put, 23 will get put into this, so 0x17. So let's hit our next instruction. And as you can see, it gets put in right here. Our 0x17, our 23 is put right there. Perfect. So let's look at the index pointer again. And we have another move long, and this one is the string hello. So let's have a look. Whoops, wrong terminal. So it's going to move it in 4 from the EBP, so 3, and of course this is where the hello is going to go. So I'm just going to hit next instruction. We got this pretty well figured out, and as you can see, this value right here was just moved into this area here, replacing what was just a null value right here. So now we have everything on the stack. We have our 0xf, our 23 that fit in here, and our hello. So this is how stacks are created. To know how to do a buffer overflow, you need to know the basics of this kind of stuff here. If I just hit continue, the process exit normally, and that's how stacks are created. I hope you guys enjoyed. I'm going to be traveling for the next couple days. So yeah, keep your comments coming. Any questions, ask away. I'm here to help. Just putting together my training package for my Ukrainian friends, and I hope it's going to be very helpful for them. I'll be posting stuff as I do to you guys, and I hope everyone's having a great week. Take care, guys.